Hey, so in this video, we're going to be using symmetry to graph quadratic functions. But first, let's talk about the axis of symmetry. What exactly does the axis of symmetry do? Well, the axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. So it looks something like this. So how do we know what the vertex of a quadratic function is in vertex form? Well, let's remember what vertex form looks like. So here we have vertex form, and our vertex are the points H and K. And it's, in our example, it's this point right here. Now when we talk about symmetry, what we mean is that if we have to move one spot to our right here, and that's our point, that one spot to the left would give us the same point at the same level and the same distance apart. So why don't we try that in an example so we can get a little bit better idea. So here we're being asked to graph the equation f of x equals -2 times x plus 4 quantity squared plus 1. And so here we can see that we have an h of a -4, because remember, if it's on the inside, it says one thing and does another, and we have a k of a +1. So we're able to write down what our vertex is. So here we have that our vertex is at -4, 1. Well, what about our axis of symmetry? What's that? So our axis of symmetry, I'm going to write AOS for short. Our axis of symmetry is going to be the x value of our vertex, because that's what allows our line to, well, that's where our line passes through, is the vertex, which creates that symmetry. And so here we're going to have that our x-axis is at x equals -4. And so if we're going to graph using symmetry, we're probably going to want to make a table. So we're going to make an xy table, and remember that y is the same thing as our f of x, right? And so what we're going to want to do is have 5 spots. And we're going to put our vertex here in the middle, because that's the middle of our symmetry. So we're going to go ahead and put in our -4, 1. And then we want two numbers that are bigger, so -3 and -2. And we want two numbers that are smaller, like -5 and -6. Now, because we're graphing using symmetry, and the distance from -4 to -3 is the same as the distance from -4 to -5, that tells us that our answers from -5 and -3 will be the same. And that happens because this is going to be squared, right? So we get this U shape, this symmetric U. And the same thing applies to our -6 and our -2, because -2 is the same distance from -4 as -6 is from -4. That means our answers from -6 and -2 will also be the same, which means we only have to plug in the numbers once for each piece. So let's go ahead and let's plug in our -3 first. And so here you can see that we've plugged in our -3, right, which is going to be the same answer as our -5. And so when we plug that in, we're going to get a -1. So let's go ahead and we can put that in our -3 and our -5 spot. And now we're going to go ahead and we're going to plug in our -2. And remember that we said that when we plug in the -2, that's the same answer as if we were to plug in -6. The reason I chose -2 is because if I was to do this on my own without a calculator, working with a -2 might be a little bit easier than working with a -6. But let's go ahead and plug this into our calculator. And we're going to get a -7. So let's go ahead and let's plug that in. And now we have all of our symmetry and we're ready to graph. All right, so we're going to see that we're mostly in the fourth quadrant here. So when I set up my coordinate plane, I'm going to put my x-axis right there and my y-axis right there. And now we're ready to graph. So I personally like to start off by graphing my vertex first. I'm going to go ahead and do that. So -4, 1. And then I'm going to start plotting my points. So I'm going to plot -3, -1. And then I'm going to plot my -2, -7. I'm plotting my -5, -1, and my -6, -7 is going to be really easy, especially if I think of my axis of symmetry when I do it. Remember that our axis of symmetry is a line, a vertical line that goes through our vertex. And my points are going to be symmetric. So here I was one place away. So I'm going to be one place away, but on the same y value. And so plotting my point, -5, 1, was really easy. Likewise, here I see that I'm 1, 2 places away. So I'm going to go 1, 2 places away, and I can plot my next point, -6, -7, really easily. So now I just need to connect my dots to make my parabola. Just like that. Now remember, it did ask us to label our vertex and our axis of symmetry. And we've done that once already by writing down what our vertex is and what our axis of symmetry is, but also then in our diagram on our graph, we've labeled the actual vertex point as well as the axis of center, our axis of symmetry's line. And so that is how you can graph using symmetry for quadratic functions.